Greetings, students. This is Dr. Mateki, and this is the first of what's going to be a series of short videos throughout the course. So the idea is that we're going to go through some of the highlights and some of the more difficult things and solving problems, etc. So I know the attention span for videos of this sort is not more than about 15 minutes or 20 minutes at the most. So I'm going to try to keep these short. This chapter has a lot of stuff, though, so it's going to be hard to keep these short. This chapter is really important because it sort of builds the foundation upon which we are going to build throughout the semester. So these are really sort of core ideas that we're going to expand upon. We're going to make some very sort of rigid assumptions at the beginning, and then we're going to start to relax those assumptions over time, add more complexity to the model, see what happens when things don't go exactly according to plan, and that sort of thing. So it's very, very important to have a good sense of the foundation, or the basic model of the macroeconomy. So in Chapter 3, there's a couple of primary ideas that we're going to focus on. So we're going to focus on building a very basic model of the macroeconomy. So this model is going to tell us how the economy produces output and how the income that is derived from that output is distributed to the members in society. We're going to talk about how the factors of production are determined. Remember, the factors of production are the things that businesses use to produce final goods and services. So things like labor and capital and technology. And again, how that income is distributed to capital owners and labor owners in the economy. We're going to talk about the demand side of the economy, which is the demand for the final goods and services that businesses produce. And then how all of these markets work in conjunction, and we end up with what we call a general equilibrium. General equilibrium is when all markets in an economy are simultaneously in equilibrium. I first want to start by looking at this slide that comes from the textbook and also the lecture slides on D2L. And by the way, I do recommend looking at the full lecture slides that are on D2L, and you'll notice that there are even some nice notes in the notes section below the slides. So there's lots of good information there. It is helpful to download the slides and play the slideshow, so then you can see the transitions and that sort of thing. It makes the presentation more intuitive and easier to understand. So in any case, what this is essentially an economic model. So in the first introductory chapters, we learned what an economic model is. It's basically a simplification of reality. So this is the entire economy in graphical form, in very simplified form. So essentially, these yellow boxes here, here, and here show us the participants in the economy. So we have three different types of agents, essentially. We have households. These are... we usually think of these as the consumers in the economy. Businesses that we call firms, and then the government sector. Households, firms, and the government interact in markets. That's where people get together to exchange things. So for instance, households and firms interact in the market for the factors of production. Firms pay households for their labor and capital. That becomes the income for households. So if we follow these green arrows, right? So firms are going to purchase labor and capital from households. This becomes the household income. Households then turn around and use the money they've earned to purchase goods and services that they need to survive. And then that becomes firm revenue. And the whole cycle starts over again. We can also see that households, the government, and firms interact in both financial markets and the markets for final goods and services. So the first part of this chapter is going to be about describing the supply side of the economy, in other words, the production side. So it's going to talk about the behavior of the firms, and it's also going to talk about the interaction of firms and households in the market for the factors of production. Then we're going to turn to the demand side of the economy, which describes the interactions of households and firms and the government in the market for goods and services. So it's going to talk about how households decide to consume things, how firms decide to invest in final goods and services, and how the government decides to purchase things. And then finally, we're going to talk about the interaction of borrowers and savers in financial markets. Financial markets can be pretty complex, but we're going to boil this down to the most simple form possible. So essentially, financial markets are a place where people that need money for investment projects can go to borrow money from people that haven't spent all of theirs. So essentially, households, if they don't spend all of their money on consumption, right, they can put some of their money into financial markets. And this takes the form of deposits and savings accounts and checking accounts, and putting it into the stock and bond markets through different financial firms and that sort of thing. And then firms and sometimes individuals, right, if they're going to buy a house or a car, will tap into those financial resources by borrowing through those same institutions. The government, although it hasn't done much of this lately, can have some money left over after they collect taxes from households. If they have any money left over, that becomes additional savings. We call that public savings that can be tapped into by consumers and investors. So again, this is a sort of schematic diagram, and so what we want to do ultimately in this chapter is to develop a little bit more sophisticated model by using mathematical equations. So what we're going to do is come up with some equations that determine the behavior of firms and households, and shows how they interact in markets, basically incorporating the laws of supply and demand, the notion of equilibrium. This is all stuff that you've done in Eco 201 and 202. It's just going to be sort of step up in terms of complexity. Here's a brief outline of the model that we're going to develop. And again, this video is just going to focus on this first part here, the supply side of the economy. But a couple of terms I want to point out. A closed economy simply means that we are looking at just one economy. We're not looking at international trade and interactions between different economies. So we're assuming that there's no trade amongst countries. Market clearing means that prices are flexible, and any sort of shortages and surpluses in markets are going to be eliminated, and markets are going to end up in equilibrium. This just means that prices are flexible and markets behave like we assume they did in Eco 201 and Principles of Microeconomics. Later on, we'll talk about instances where prices don't always adjust to equilibrate supply and demand, and so that's the sort of notion of sticky prices that Keynes introduced to macroeconomics. So for now, we're going to be assuming that prices are flexible, and that's a good assumption in the long run, because over the long run, prices indeed do have time to adjust, and in the short run there may be some frictions, but in the long run those things go away. So again, we're going to talk about the supply side. So we're going to talk about how firms decide how much to produce, where that income goes, and how that is distributed, how that income is distributed to households via the factor markets. And the factor markets is very much a basic supply and demand story, like that you've seen previously. In some ways, the supply side of this economy is very simple. The amount of stuff that the economy produces is governed by something we call the production function. The production function, if you remember, shows us how we can combine the inputs, the factors of production, in this case capital and labor, into output, which we use the letter Y to describe that. The production function also reflects the economy's level of technology. So these are the ideas and the knowledge and the skill that is used to transform the physical inputs into finished goods. We'll make that more explicit later on when we talk about a specific form for the production function. This is just sort of a general functional form. Later on, we're going to talk about the Cobb-Douglas production function, which gives a specific mathematical form to the production function. So there's also a big section in the book about returns to scale. So the important thing to understand is that the production function for the aggregate economy, if you look at the actual data, it reflects constant returns to scale. So the basic idea there is that if you double the inputs, you also double the output. That's what constant returns to scale means. If you had decreasing returns to scale, you could double the inputs and get less than double the output. The same and vice versa for increasing returns to scale. So the important thing is that the aggregate economy, the economy as a whole, exhibits constant returns to scale. So to make this simple, we're going to make some assumptions. So all economic models involve assumptions. Some assumptions are better than others. The validity of a model oftentimes depends on how good your assumptions are, how realistic, how appropriate are they. In this case, we want to make this very simple, so we are going to assume that technology is not changing. we are going to assume that the supplies of capital and labor are also fixed. So when we say fixed, we use this little notation here, the little bar over the variables. So this is read K bar, L bar, and Y bar. So K bar just means that there is a fixed quantity of capital. L bar means there is a fixed quantity of labor. If technology is fixed and the supplies of capital and labor are also fixed at some known quantity, then the production function tells us that we're going to get some fixed quantity of output, or GDP, as well. Is that realistic? No, but that's where we're going to start. We're going to start with a very simple thing, and we're going to see what happens over time in later chapters as we allow capital and labor and technology to change, and now we're starting to talk about a dynamic process of economic growth. But we're going to start off by assuming these things are fixed. So in the last slide, we looked at how the goods and services are produced in the economy. So who gets all of the income that's generated by the production of those goods and services? So that's what we refer to as the distribution of national income. So ultimately, the distribution of income is determined by factor prices. So remember, the factors of production in this model are capital and labor. And so the factor price for the labor input is the wage, and the factor price for the capital input is the rental rate. So these are essentially the prices that firms pay for the use of inputs, the wage and capital inputs. Now, oftentimes firms actually own the capital, so this gets a little bit messy, right? And so a lot of times what we think of as profit on the firm level is actually the returns to the capital that they own. Some notation that you need to be aware of that we're going to use throughout the rest of this chapter. W stands for the nominal wage. So this is just the typical $10 per hour or $20 per hour wage that you normally would think of. So this is in terms of dollars. The nominal rental rate is capital R, so later on we're going to use lowercase r for interest rate, so don't get those two confused. So the nominal rental rate is, again, the dollar amount that is being paid to capital owners for the use of their capital. P is the price of output. And so I want you to really focus on what we call the real wage and the real rental rate. So the real wage is what we get when we take the nominal wage divided by the price of the output. So imagine you worked for a t-shirt factory. Your real wage would be measured in terms of t-shirts, so that at the end of the day, the owner gives you a couple of t-shirts for your wage. Now that's not very useful, right? So you can't just turn t-shirts into whatever you want. So we instead choose to get paid in money. But we do this to control for the effective prices. So we're more concerned with the purchasing power or the real value of the wage, not necessarily the effective price changes. And so that's why we use the real wage. So that's more important for decision making. And the same thing holds true for the real rental rate. That's what drives firm decision making. So how are the real wage and the real rental rate determined? Well, these are a type of price, and we know prices are determined by the forces of supply and demand in markets. And in this case, we're concerned with the labor markets and capital markets. So a job is posted at Burger King for $15 an hour, and you go and apply. That's the labor market. It's not anything more complicated than that. So remember, we are assuming that the supply of the factors are fixed. So what this means is that the number of workers and the number of hours, that's all just a number. It's determined. It's not variable. Now, demand's a different story. So where does the demand for the factors come from? So the demand comes from firms, from businesses. So businesses hire you. That's purchasing your labor in the labor market. They rent capital or they buy capital. So it's a similar sort of situation. So how much labor and capital are they going to purchase? Well, that's going to depend on what firms are trying to accomplish. So we have to make an assumption about how firms behave. And so from lots of experience and observation and collection of data, we come to the conclusion that firms try to maximize profit. And, there are different ways to conceptualize this idea of profit, but at the end of the day, firms are trying to make money. It's a pretty good assumption. So from the firm's perspective, what are they going to do? Well, they're going to hire workers and they're going to rent or buy capital in a manner to maximize their profit. So as long as the benefit to hiring additional workers exceeds the cost, they're going to hire more workers. Same for capital. So from the firm's perspective, the real wage rate and the real rental rate of capital are taken as given. That means that we are, again, making an assumption that these input markets, these factor markets, are competitive. There's lots of sellers. And firms don't really have any ability to control the price. They just simply look at the market rate, and that's what they have to pay. So they're going to hire workers and rent the amount of capital that maximizes profit. So there's a much longer description in the textbook, but the basic idea is that firms are going to hire one more unit of labor if the benefit exceeds the cost. The cost in this case is the real wage. That's what they have to pay the worker to encourage them to come work for them. The benefit that the firm gets is what we call the worker's marginal product of labor. So if we hire one more worker, how much does output increase? And so that's the definition of MPL, the marginal product of labor. It's the difference between our initial production level and the production level after we hire one more worker, L plus one, compared to the situation where we have L workers, holding all other inputs constant. How much additional value does that worker create? Right? That's the benefit to the firm. If we were to graph that production function we talked about earlier, it would look something like this. So when we graph a production function, we typically put labor, represented by L, on the x-axis, and output, represented by Y, on the y-axis. And notice the shape of this production function. It increases. So as we move to the right along the x-axis and add more labor, output is increasing. That makes more sense. More workers, more output. But what we notice is that this production function tends to flatten out at the top here. So what that tells us is that as we add more and more workers, the extra output, the additional output that those workers are creating, is getting smaller and smaller. So in other words, the marginal product of labor, the additional contribution from the next worker, is getting smaller and smaller, or diminishing. So this is typical of most inputs. So as we add more and more of the input while holding all other inputs constant, we get diminishing returns to that input. Eventually, we can add 10,000 workers, and the 10,001st worker isn't going to actually contribute much additional output. It's also important to note that the marginal product of labor is the slope of the production function. So at the bottom part of this graph here, we notice the slope is rather steep, and at the top, the slope is much flatter, indicating a smaller marginal product of labor at higher levels of L. To further drive home this notion of profit maximization, let's look at a quick graphical example. So this chunk we have here on the left, this column with the L and the Y, this is essentially our production function. So we're looking at how much output we get for varying amounts of workers. So with 0 workers, we don't get any output. With 1 worker, we get 10 units of output. With 2, we get 19, etc. Now, the marginal product of labor looks at how much additional output each worker contributes. So when we go from 0 to 1, we get 10 additional units of output, so the marginal product is 10. When we go from 1 to 2 workers, we go from 10 to 19 units of production, so in other words, we increase by 9. The second worker contributes 9 additional units of output, and on and on. So let's suppose the firm looks at the market wage and they say, okay, if we're going to hire a worker, it's going to cost us 6, right? Remember, this is the real wage, so this is measured in terms of output. So it's going to cost us 6 to hire a worker. How many workers should we hire? In other words, what is the demand for labor given this production function? So, well, let's consider a couple possibilities. So what if L is 3? What if they decide to hire 3 workers? Well, the third worker contributes 8 additional units of production, and we only have to pay them 6. So is that a good deal for the firm? Absolutely, right? The benefit to the firm is 8 additional units of production. They only have to pay them 6. So yeah, that's a great deal. In fact, as long as that's the case, as long as the benefit exceeds the cost, we should keep hiring more workers. What if we're at 7 workers? Well, now that seventh worker is only bringing us from 45 to 49, so they're contributing 4 additional units. If we have to pay them 6 units and they're only giving us 4, that's a bad deal. So now we've hired too many. So where's the sweet spot? Well, we want to find the spot where the real wage, W divided by P, is exactly equal to the marginal product of labor. So in this case, we can easily identify that spot right here. So what we would say is that this firm is going to choose to hire 5 workers because that worker is just now covering the cost of the wage with the extra production that they're contributing. So if we go to 4, we can benefit by hiring an additional worker. If we're at 6, we can actually make ourselves better off by laying someone off, getting rid of a worker. So the key takeaway here is that when the firm is maximizing profit, doing the best that they can, W over P is equal to the marginal product of labor, right? This is what we would call our profit maximizing condition for the firm. So in that last table, the profit maximizing behavior indicates that the firm is going to compare the wage rate that they have to pay to the marginal product of labor. In other words, that marginal product of labor is very, very important for determining how many units of labor that the firm is going to demand. In other words, this is the relationship between the price, in this case given by the real wage, and the quantity demanded by the firms. So remember, the relationship between price and quantity is what we call a demand curve. So the marginal product of labor really is equivalent to the labor demand curve. So for any given real wage, we would just simply go over to the demand curve and drop down, and we would see that firms would be, see which quantity of labor firms would be willing to hire at that wage. Remember that the shape of this line, this is downward sloping. This makes sense because the marginal product is diminishing. More labor is hired, the marginal product gets smaller, so this line should be downward sloping just like we should expect. And this also makes perfect intuitive sense. At extremely high wages, firms don't want to hire very many workers. At low wages, the quantity demanded of labor is going to be much higher, right? So the worker doesn't have to be nearly as productive if the wage is low for the firm to be willing to hire them. So now putting supply and demand together gives us a sense of how the equilibrium real wage is determined. So remember, the labor supply is fixed, so it's just fixed at some number here. So regardless of what the wage is, the quantity of labor doesn't change, so we just get this vertical line. The demand for labor is the downward sloping MPL curve that we just talked about. And of course, we know from principles classes that equilibrium occurs where the supply and demand curve intersect. So if we go from the intersection point over to the y-axis, this will give us the equilibrium real wage. Now, just to imagine what would happen if the wage were higher than the equilibrium wage, well, then the demand would be a lot less than the supply. That would create a surplus of labor, and that would drive the price down. If the wage were really low, then the demand would be greater than the supply, creating a shortage, which would drive the price up. And so given time, the wage is going to adjust until we reach the equilibrium at the intersection of supply and demand. There's a completely analogous exposition that we could do for the capital market. It looks exactly the same, so check that out in the text. So just like we learned that the real wage is going to be equal to the marginal product of labor in equilibrium, the same is going to be true for capital. The real rental rate is going to be equal to the marginal product of capital, which we usually shorten up to MPK. So with capital, there are diminishing returns as well. So as we use more and more capital in production, the additional contribution to output of those units of capital is diminishing. In other words, the marginal product of capital is falling as K gets bigger. So similarly, the MPK curve is the demand curve for renting capital, and the real rental rate in equilibrium is going to be at the intersection of the supply and demand of capital. And so again, this is a profit maximization exercise by firms. So they're gonna keep renting more capital until the benefit, which is the marginal product of capital, is just equal to the cost of acquiring the capital, which is the real rental rate. And so now we're going to continue our discussion of how income is distributed to the owners of the resources, the labor owners and the capital owners. So if we want to figure out how much of the total pie is going to workers, well, we know that workers are being paid the real wage, W over P, and there are this many workers, there are L-bar workers, so the total amount of money going to the workers is going to be the amount they're getting paid times the number of workers, W over P times L-bar. We know in equilibrium from profit maximization that the real wage is going to be equal to the marginal product of labor. So we can simply substitute MPL in for W over P and say that the total income that's going to, oops, I just noticed there's a typo here. This should be labor income, not capital income. It's a typo in the slide. The total labor income should be the marginal product of labor times the number of workers. Okay, so now I fixed this for you here. So this is actually labor income. So total capital income, we use the same logic. So the capital owners are getting paid R divided by P per unit of capital. K bar is the number of units of capital. So the total payment going to capital owners is R over P times K bar. We know that in equilibrium, profit maximization means that the real rental rate is going to be equal to the marginal product of capital. So another way to rewrite this first expression is to say that the total payments going to capital owners or total capital income is the MPK times the amount of capital K bar. So now we can make some further assumptions about the production function having constant returns to scale. And we can assume that, again, we've made the assumption that markets are competitive, so the markets for capital and labor are perfectly competitive. And so if all those things are true, what this means is that all of our GDP, again, so remember GDP, income, production and income, those are two sides of the same coin. So here we're saying total production, which is the same as total income, is all divided amongst the labor owners, the laborers, the workers, the labor owners sounds kind of awkward, the laborers and the capital owners. So in other words, there's nothing left over for what we would call pure profit. So that doesn't mean that there isn't profit showing up. So in an accounting sense, since the firms oftentimes own capital and own land that the factories and things are on, there are payments going to the owners of the firm that are comprised of this returns to capital. So all of the income in the economy either goes to the workers or to the capital owners. So even though this expression means that there is zero profit, remember we're talking about zero economic profit, which still means there could be an accounting profit. So zero economic profit means that you're not making any profit above and beyond the opportunity cost of the resources employed. So if you go to the Bureau of Economic Analysis, which is the main repository for economic data for the government, so we could actually measure all of these things, right? We could measure how much of national income is going to workers and how much is going to capital owners. And we see over time that it's kind of remarkably stable, right? So it looks like the share of income that is going to workers between 1960 and 2000 anyway was remarkably stable at right about 70%. So 70% of all income is going to workers, in other words. So it does fluctuate up and down, but seems to average about 70%. And so now notice since 2000, there's been this little downturn. So it actually looks like less of national income is going to workers, which means that more is going to capital owners. And so this has been part of a broader discussion about inequality and the returns to capital and how capital owners are becoming more wealthy than laborers. And so this is something that I want to incorporate into a discussion board assignment that you'll be getting shortly. So again, just to summarize, the top of the y-axis here is 1, so this just means that this is like 100% of national income. So the fact that this line here is at about 0.7 tells us that 70% is going to labor, and since all of national income is shared between labor and capital, the remaining 30% must be going to capital owners. So up until now, we've been talking about the production function in just very general terms. in this sort of y equals f of k times L, or f of k and L. So this is just a general functional form. It doesn't tell us exactly how we combine capital and labor and technology to produce output. So if we want to actually derive any numbers and do further analysis or research, we need to actually have a specific production function that we use. So typically in economic research and models of this sort, we use something called the Cobb-Douglas production function. And so the key reason why we would use this is because it has this nice property of having constant factor shares. In other words, just like the data showed in the previous slide, if we use this Cobb-Douglas production function, it's going to generate constant shares of income going to labor and capital. So the Cobb-Douglas production function looks like this. So it's y equals a times k to the alpha times L to the 1 minus alpha. So this parameter alpha here, so again, we're raising k to the power of alpha. Alpha represents capital's share of total income. So looking at the previous slide, when we said capital was getting about 30% of national income, this alpha should be 0.3, representing the fraction of income going to capital. So the rest, of course, goes to labor, so 1 minus alpha. If alpha is equal to 0.3, for instance, then we'd be raising L to the 1 minus 0.3, or L to the 0.7 power. A represents this term we're sort of sticking on the front, which represents the level of technology. So if A is bigger, that means we're going to be getting more output for every amount of capital and labor that we put into the process. So it's allowing us to combine inputs more efficiently to produce output. Let me draw your attention to this section in the middle here. So capital income, remember in the previous slide we said that total capital income is the marginal product of capital times K. So this simplifies down to alpha times Y. So remember, alpha is capital's share of total income. So if total income is 10 and alpha is 0.3, then that means capital owners are getting 3 units of output for total income. Likewise, labor income from the previous slide, MPL times L, was our total payments to workers. That boils down to 1 minus alpha times Y. So in other words, if alpha is 0.3, then workers are getting 70% of output. If output is 10, then workers are getting 7 units of output as their income. Once we have a specific functional form for the production function, that allows us to actually have a specific form for the marginal product of capital and the marginal product of labor. So if we have our Cobb-Douglas production function, we can find the marginal product of capital by doing a little bit of calculus. So we would take the partial derivative of the production function with respect to k, and we get this expression here. I don't care if you're able to find that or not. If you know some calculus, have some fun and try to find it. If not, just know that this is the number you get for the marginal product of capital. And it actually, with a little bit of algebra, we can simplify it down to this expression here, right? So when it says the marginal product is proportional to its average product, so if this is our marginal product, right, y divided by k is the average product, so the total output divided by k would be the average amount of output per unit of capital. So saying that it's proportional, it simply means we're multiplying it by some factor a. Similarly, with the marginal product of labor, we could take the partial derivative of the production function with respect to L, and we get this expression here. With some algebra, we can convert it to a simpler form here. So the marginal product of labor is given by 1 minus A times Y over L, again, where A is the alpha term from the previous slide. I just now realized that this somehow converted from alpha to A. So A here is our capital share of income. This is our exponent in the Cobb-Douglas production function. So 1 minus A, or 1 minus alpha times Y over L, is the expression for the marginal product of labor that you will be using. So these things are very useful here. These last two expressions are very useful for problem solving. Suppose that you had a problem where you wanted to figure out or solve for the real wage. So we know that the real wage, W over P, I'm just going to write this out. So the real wage equals W over P. We know that in equilibrium, the real wage is equal to the marginal product of labor. So now we have some information here that we can use. We can say that W over P is equal to the marginal product of labor, which is given by the expression here. So let's simply set that equal to 1 minus A times Y over L. Right, so using this sort of expression is going to be a way for you to solve for the real wage in a problem. Right? So for instance, what if we wanted to examine how the real wage is going to change when labor increases by 10%? Well, we can calculate the real wage at a level of L, and then we can say, all right, well, what is the real wage when L is 10% bigger? In other words, instead of L, what happens when we have 1.1 L? Okay, so you have to keep in mind that when we change L, we're also changing Y, because L is a factor of production, and so if L goes up, we know that Y is going to go up. So there are lots of things changing, and that's going to be one of your homework problems for you to explore. So just giving you a few hints there about how to attack those problems. So again, the neoclassical theory of distribution suggests that the amount of money going to workers is related to their productivity. So the wage rate is related to how productive they are, and in other words, their marginal product. So if a worker is very productive, they're going to have a high marginal product of labor. So if we look at data from various time periods, we see that there's a really close relationship between how productive workers are, in other words, how big their marginal product is, and their wage rates. And now this is in growth rates. So what we can say is that between 1960 and 2019, on average, productivity grew at 2% per year. During that same time period, real wages grew at 1.8% per year. So it doesn't match up perfectly, but there's a high degree of correlation. So while this theory doesn't tell the whole story, certainly does a pretty good job of explaining the basic relationship. Now, one thing to keep in mind is that there is these are growth rates, and so that even small changes in growth rates over the course of 60 years can lead to big discrepancies. So there is some ongoing research based around the idea that, well, maybe wages are not as closely related to productivity as they used to be. Another thing to point out is that since about 2010, and this is really before the last year or so when things have started to change really rapidly, wages are rising quite a bit in the last year. But there's been a long period of time where productivity has been low and wage growth has been low. And so this is a big concern for economists, because if wages are not going up over time, the standard of living is not going up over time, we're not getting better off over time. So what is causing this low productivity, which leads to low wage growth? How can we solve that? Those are key questions that economists are thinking about these days. And that's all I have for part one of these slides. So again, this took way longer than I intended, so I apologize for that, but hopefully you found this useful. And as always, ask me questions, email, or use the discussion board if you need further clarification or need something else explained.